Hey everyone. So welcome to our first lesson, which is all about functions. This is 11.1 from Unit 11. So today we're going to figure out what a function is. Now it might sound tricky, but don't worry, I'll explain everything step by step, so it's super easy to understand. After that, we'll try some fun practice questions from our book together. If you want to try them on your own first, just pause the video, give it a go, and then press play to see how I solved them. So all you need is a notebook, a pencil or a pen, and let's get started. Let's first start by trying to understand what a function is. And for us to understand that, I'll be using numbers first, and then we'll be using x's and y's to sort of give you a general overview of what the lesson is about. So in front of you is a machine. And if you do not know what this is called a conveyor belt. And the whole idea is I will place something at the start of the machine. It will go through this box and it will come out as something else. So if I, for example, put the number 5, this machine, and then it will go through the box and it will come out as 11. And the way that happened is because we added a 6 here. So let's say the function of the machine, so this is the function of the machine, is to add 6 to whatever number gets put on the conveyor belt. Variables like x. If you remember what we've done in Unit 9, you would probably realize that, hey, I've seen this before. This is called a function machine. We've done it, and it looks something different, right? So this is just a visualization of what we've done in Unit 9, but we will be needing it for Unit 11 as well, which is for graphs. But thing is, every time we will input a number, let's say this time we'll input the number 7. It will go through the process. It will be 7 plus 6, and 7 plus 6 is 13. And then we can put another number in. Let's say the number 8. 8 plus 6 is, again, 14. So the numbers at the start go through the same process every single time. But what if we wanted to show the general function of our machine? What if we wanted to show the general relationship between what comes in and what goes out? That's why we'll be using variables like x and y. So I'll be placing x at the start, so they will replace all of the numbers that could be there, and I will replace the numbers that go out by y. So the only thing that does not change is the function of the machine itself, which is adding 6. And if we were to write it algebraically, it would be x plus 6 equals y. And x plus 6 equals y is called a function. So, in other words, we are describing a relationship between what goes in the machine and what goes out of the machine. So if we were given a definition for what a function is, we would simply say a function describes the relationship between two variables, for example, x and y. Now, you might ask, can I call these variables something else? And this honestly depends on the exercise you have in front of you, but I technically could. I could call x any other letter I want if I'm given the freedom. Let's, for example, call it O, and O plus 6 would be equal to T, for example. So this is basically what a function is. And now we might just move on to some example exercises so you would have an idea what you should be doing on the day of the quiz. So this is question 1 from your learner book. It's actually page 227 for those interested. So let's start by reading it first. So question 1A says, Angelo is twice as old as Sabrina. And all they're asking for now is how old is Angelo when Sabrina is 4 years old, 6 years old, 10 years old, and 12 years old. And we could use the same function machine we talked about at the start to solve this. So let's say that Sabrina's age will be what's going to be put at the start of the machine. And Angelo will be the age that comes out. But question is, do we really know what the function of the machine is so far? And if your answer was no, you should have probably read the question again. And if your answer is yes, and you've said that the function of the machine is for us to multiply whatever we get by 2, then you would be on the right track. So, just like we did at the start, to answer the first part of the exercise, all we have to do is place the number 4 at the start of the machine. 4 will get multiplied by 2. It will come out as 8. We will place the number 6. 6 will get multiplied by 2. It will come out as 12. We'll place the number 10. 10 years old. So it will get multiplied by 2. There we go. It will be 20. 10 times 2 is 20. And finally, we'll place the number 12. I'll just place it at the bottom because I don't have any space. 12 multiplied by 2 is, of course, 24. So if you were paying attention up until now, you would know that the first part of the machine represents Sabrina's age, right? So we are grabbing Sabrina's age. We're putting it in our machine. We are multiplying Sabrina's age by 2. And then what we will get in the end is Angelo's age. So let's write Angelo's age right here. And this is for a reason, of course. Now, let's look at question B. When Sabrina is S years old, how old is Angelo? When Sabrina is S years old. So this time they did not give us a number, they gave us a variable. But are we supposed to get stuck? Are we supposed to ask, hey, where's the number? I don't see any numbers. Well, no, because you will do exactly what you've done with these numbers here. Instead of putting a number at the start of the machine, all I'm going to do now is write down the letter S. And S goes through the same process. It gets multiplied by 2. So in the end, it will come out as 2S. For those unaware of why it became 2S and not 2 times S, is because it's an algebra rule that we've seen in Unit 2, where we don't have to include the multiplication sign when we're multiplying a number by a variable. So if Sabrina is S years old, how old is Angelo? The answer simply is 2S. All right. Now, question C says Sabrina is S years old, and Angelo this time is A years old. And we will copy and complete this function. So A is equal to something, something. Now, what is that something? So let me take you back a bit. Remember when we said, let's stop using numbers altogether, and let's write the general form of it. And we wrote X here, and then we wrote Y here. But then I brought to your attention to a question that you might ask. And you said, hey, could we write something other than X and something other than Y? This is where you actually need to, because Sabrina here is not X years old. This time, Sabrina is S years old. So the number at the start, or the variable at the start, should be called S. And this is what the exercise has told us. And Angelo's age is A years old. So instead of writing Y, we will write A. Now I'll give you, let's say, a couple of seconds if you want to pause the video and try to write down on your notebook what A could be equal to. Now I assume you unpause the video right now. A would be equal to 2S. How did we figure that out? Because simply enough, S multiplied by 2 equals A, right? So let's write that down. So S multiplied by 2 equals A. But hey, can we write it as S multiplied by 2? Of course not. This is algebra. It's a variable and a constant next to each other. So 2S equals A. Flip it around, it will be A equals 2S. And that's basically how we would answer question 1. So question 2 is a bit different. And it reads, Lila's mass is 3/4 of the mass of Abdul. So if you remember Unit 7, I think, it was about fractions. So I'm not sure about the number of the unit itself, but the unit was about fractions. And we agreed that 3/4 of something would mean that we're multiplying that something by 3/4. So let's read the question again. Lila's mass is 3/4 of the mass of Abdul. And A says, if Abdul's mass is 40 kilograms, what is the mass of Lila? Now, so we will place Abdul's mass at the start of the machine. Now this 40 kilograms will go through the conveyor belt, it will get multiplied by 3/4, and that's how we will find Lila's mass. How is that done? Using fractions. Easy. So we will grab this 40 kilograms, we will multiply it by a fraction, 3/4. Now, if I'm multiplying a whole number by a fraction, you should know that I will multiply 40 by the numerator, which is the upper part of your fraction, and then I'll divide by whatever is at the bottom, at the denominator, which is 4. So that would give us an answer of 120 divided by 4, which should give us 30 kilograms. Meaning that when 40 kilograms goes into the machine, it should come out as 30 kilograms. And this is exactly how you would need to write your answer if I tell you to show your work. So you'd write this. Let me take a screenshot of it. So it will be something along the lines of this. So this is the answer for question A. Now, B says, write down 2 more examples of the possible masses of Abdul and Layla. And a lot of you get confused by this. But it's quite simple. When they say the possible masses, they are giving you the absolute freedom to choose whatever values you want for Abdul. And from the value of Abdul's mass, you will find the mass of Layla. So let's pick 2 values, and they could be crazy values, by the way, because it's still mathematically correct. Let's say Abdul weighs, I don't know. Let's say he weighs 4 kilograms. Let's say Abdul weighs 4 kilograms. He has lost a bit of weight, but he took it too far. So now it would be 4 multiplied by 3/4. So let's replace this 40 by 4. So it would be 12 divided by 4, which means Lila's mass is 3 kilograms. So 3 kilograms here. So this is your first value. And let's pick another absurd value for the fun of it. Let's say Abdul weighs 400 kilograms. He got bored with his diet, so now he decided to eat as much food as he can. So, but it would still go through the same process. So 400 multiplied by 3/4 would be 400 times 3 divided by 4, which would be 1200 divided by 4, which should give us 300 kilograms. So Lila's mass is 300 kilograms when Abdul's mass is 400 kilograms. And this is important because this is how you should write it down. When Abdul is 4 kilograms, Lila's mass is 3 kilograms, I'm sorry. And when Abdul is 400 kilograms, Lila's mass is 300 kilograms. So this is the answer to B. Now let's read C together. So C says Abdul's mass is X kilograms and Lila's mass is Y kilograms. Copy and complete this function, Y equals something. This is the same thing. So we said that Abdul's mass should go at the front. So let's replace the values that we input by just the variable X. And let's replace what comes out of the machine by the variable Y. So let me replace that. So what would our answer be? Simply enough, X multiplied by 3/4 would give us Y. So this is how it should be written. So 3/4 X would be equal to y. Simply enough. Why did we not put a multiplication sign? Again, this is algebra. Even if you're multiplying a variable by a fraction, it will still be written this way. 3/4 x equals y. Now let's flip the script a bit. If 3/4 x equals y, that would mean y equals 3/4 x. So all I need to do is grab this 3/4 x and place it in front of the y that they already gave us. And this is the answer to question 2. Another quote-unquote different question is one that involves geometry. Now, you might see in front of you, and I've seen some confused faces when we've done this together in class, but worry not, treat the problem as it is. What I mean by this is try to give it a chance. Just because you have a triangle in an algebra unit does not mean that it's the end of the world. And we will see together why is this. So question 4a says, this is an equilateral triangle. And this is what should be going on in your head. As soon as you read the word equilateral triangle, try to remember what an equilateral triangle is known for. And simply enough, equilateral triangle means a triangle has equal sides, right? And they said that each side is 5 centimeters long. So what is the perimeter of this triangle? This is another word that you need to know regardless of whether you're doing geometry or not. Perimeter means the quote-unquote outside of the shape. So if we grab this triangle, okay? We're going to grab this triangle, we're going to borrow it, place it here. So we're basically adding this side plus this side plus this side all together. But since this is an equilateral triangle, instead of adding them all together, we could just grab one side and multiply by 3, because the triangle has 3 sides. So what could the perimeter of the triangle be if we know it's an equilateral triangle with a side of 5 centimeters? If you thought 5 times 3 equals 15 centimeters, then you're on the right path. So B follows the same logic. They said this time, the side of an equilateral triangle is 20 centimeters. So simply enough, instead of them writing 5 centimeters here, it would be 20 centimeters. But would we change anything about this? Of course not. Instead of doing 5 times 3, we would do 20 times 3. This time it would be 60 centimeters. Now, let's read question C, and maybe this might be a bit confusing, but let's try to first remember the definition of a function. A function shows the relationship between two variables, x and y. And another word for relationship would be connection. All right? So person X and person Y are in a relationship, therefore they have a connection between both of them. So let's read C. What is the connection? Meaning, what is the relationship between the length of one side of an equilateral triangle and the perimeter of the triangle? Simply enough, the side gets multiplied by 3. Right? So this is the relationship between the side of the triangle, the equilateral triangle, and its perimeter. For us to find the perimeter of an equilateral triangle, we just multiply the side by 3. And D sort of summarizes everything we talked about. Each side of an equilateral triangle is S centimeters. The perimeter is P centimeters. And we need to write down a function to show the relationship between P and S. So let's go back to this conveyor belt, this function machine, and let's sort of remember what we've done so far in the exercise. So we first put a value of 5, all right? It was multiplied by 3, and it came out as 15. We put a value of 20, we multiplied it by 3, it came out as 60, right? But then they defined what each value is. They said that each side, either it being 5 or 20, we would start calling as S. And each perimeter, whether it is 15, 60, or whatever value we would find, would be called this time P. So what happens to S to turn into P? Simply enough, we will multiply S by 3, so that would be 3S equals P. Got it? I hope you have. Now, it's not the end of the world if you write it this way, but a neater, cleaner way of writing things when you write down a function that shows the relationship between two variables would be to write the variable that is on its own first. So P equals 3S would be beautiful, would be neat, would be clear enough, and most importantly, it would be correct. So this is the answer to question 4. Now I've tried to show you what the different variations of exercises related to functions might be, and this is the final exercises we're going to cover, or the final exercise, excuse my English, that we're going to cover for this video. This is exercise 6 of your learner book. This is page 228. Feel free to try the rest at home. You're already home, so feel free to try the rest by yourself. So let's start. X and Y are two variables and are connected by the function y equals x minus 5. Let's not read A, B, or C for now. Let's just focus on this sentence. Now, this is different from what we've done for the other exercises, because for the other exercises, they usually give us a context. They usually say, hey, Marcus has X dollars and Amelia has Y dollars. What's the relationship between both X and Y? Someone weighs something, the other weighs something else. So this time it is more general. They're not telling us what the story is, but this does not change anything. Because when they say X and Y are two variables and are connected by the function y equals x minus 5, we would first need to visualize it on our conveyor belt right here. And when I see y equals x minus 5, I will probably think of this first. Y is usually at the end of my conveyor belt, and x is usually at the start of my conveyor belt. And I know that if I subtract 5 from x, I will get y. So this is the function of my machine. X minus 5 equals y. So as soon as I understand this, all of the other questions will probably be very easy to solve. So let's read A. Find 3 possible pairs of values for x and y. Again, when they say find 3 possible pairs, they're not trying to trick you. They're not trying to tell you, hey, I need this specific number. They are giving you freedom to choose whatever you want. So think of it as us doing the exercise backwards. They gave us the x, they gave us the y, they gave us the relationship between x and y. For this case, it's minus 5. But now we are going to choose our own numbers. So let's look for a few numbers that we could replace x by. And I will choose these numbers. So we have, let's say, 17. Oh, hold on. I need to, there we go. Okay. So 17, 37, and 10. Now, the reason why I picked 17 and 37 is because they're both my favorite numbers in the whole wide world, and 10 is a number that I chose randomly. Now, the reason why I'm telling you this is because for me to check if you're watching the video, write down 17 and 37, or this is what you will write down. One moment. Why did you pick 17 and 37? This is what you should write as a comment. This will ensure me that you've probably watched the video. So write that as a comment. Now, 17 goes the process of getting subtracted by 5, right? So y will turn into the different numbers that we will eventually get. So 17 minus 5 will give us a 12. 37 minus 5 will be 32. And 10 minus 5 would be 5. This would be us answering question A. Now, of course, you're not going to draw a conveyor belt on your quiz paper. I hope not. You will not have the time to do that, I'm afraid. So what you will do instead is simply write this for A, and this would be a good answer. When x equals 17, then y equals 12. When x equals 37, then y equals 32. When x equals 10, then y equals 5. Now, B is more of you thinking about real life things. For example, give 3 examples of what x and y could represent. What could the context of this be? Let's start with the example of chickens. If Tariq is watching this, you would know that this is his favorite example for everything. He likes chickens a lot, apparently. So let's say you have 17 chickens. Every year, 5 chickens die out of disease. Maybe you ate them. I have no idea. So every year you would grab your number of chickens that you have right now, and you will expect that in the end you will have 5 less. This is the first context. I will let you think of other contexts that involve -5. C is comparing your answers to part B with partner's answers. I don't have a partner next to me. You probably don't have a partner next to you. But you could discuss this together. I know this will not happen, but hey, fingers crossed. Maybe we'll talk about it more together. Maybe we'll revise this together. So this would be an opportunity for both of you, whoever you are, to talk about this. Try to find examples of what x and y could represent when x minus 5 is equal to y. And that is it for question 6. And for this video, actually. So I hope you understand functions by now, and do expect more videos in the upcoming days.